Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, let us go ahead and get rolling on 2011 question, which you can see is a pretty tough one. My hope is that you already read this through, and now that you read this through, we're gonna get started on A, B, and C. So take a moment to pause the video if you haven't to read it through. Okay, so what I really wanted to highlight here is at the beginning of 2010, a landfill contained 1,400 tons. That's your initial condition, which they actually give it to you down here. But nonetheless, that is your initial condition that tells you how much ton a landfill had. Meaning, if I was just to draw a little landfill, right, there is, let's see here. We'll use red or brownish, right? This is kind of your solid waste, and there's 1,400 tons right there. And then basically if you go over here, they're giving you the derivative function, and so that kind of tells you everything you need to know. You know it's differentiable, you know the initial condition, and they give you the derivative, so that means we're probably going to have to do separation of variables at some point, or it's could ask a variety of questions. Now let us go ahead and get rolling to part A. Use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months at t equals 1/4. Now, one thing to keep in mind is they didn't say use the equation of the line tangent. They said use the line tangent. That is the equation of the line tangent. We're trying to use that tangent line to make an approximation. So I need to write this down real quick. We need the equation of the line tangent, which I put right here. Well, what is y1 and x1? Well, x1 is 0, right? Because it told us t equals 0. That was the initial condition. And it also tells us at t equals 0, which is what we're trying to approximate. Well, at t equals 0, how much land waste is there? Well, there's 1,400. So the 1,400 is going to go for the y1, which is essentially how we got this problem down over here. Y minus 1,400 equals m, x minus 0. Now, how do we usually get m? We need to take the derivative, and then we need to plug in our values to be able to get our instant slope for that tangent line. Well, here's the good news. They gave us a derivative right over here. I kind of wrote it out for you, which they have right there. So all we need to do now is plug in our values to get it. Now they're using W, they're not using T. You know W is 1,400, so I'm gonna put 1,400 into our derivative function. Also, I don't know why I put 0 here. This should be 300 right here. 1,400 minus 300, right? That is just literally the derivative equation that is right there. 1 over 25 parentheses w, this is our initial condition, minus 300. So if we go and solve this out, we're going to get 1,400 minus 300 is 1,100 divided by 25. I'm just going to write it as a simple fraction. Now, I don't have a calculator. I don't want to do this by hand. I don't want to waste my time on the AP exam to do things that are not needed. They just want to see that you know how to make the equation of the line tangent. They don't care if it's simplified. So this is our slope. We're going to use this for m. I don't want to do that. Even I can't do that efficiently. So let's go ahead and write it out. So there is my equation of the line tangent right here. I have my initial conditions, and then I just got my slope. Now, they're asking us to basically go ahead and approximate it at approximate the amount of solid waste that it contains at the end of the first 3 months at t equals 1/4. So we need to take the 1/4 and we need to plug it into this x value right here in order to approximate how much landfill is going to be there. So let's go ahead and do that together right over here. Okay, I'm gonna put the 1/4 into here. If I do 1/4 minus 0, that's just going to give me 1/4. So I get this problem right here. And then if I rewrite this, I get 1,100 divided by, well, 25 times 4 is 100. So I get 1,100 divided by 100. Again, I don't even need to solve this out, but I guess I could do that. 1,100 divided by 100 is going to be, all right. Now, again, if you could do this in your head, awesome. If you can't, no big deal. I personally don't care to do this in my head. I'm just going to add 1,400. I wrote the 4 really bad, plus 1,400 right there. So then I'm going to write down, then I'll just write down the approximate amount of solid waste that the landfill contains at the end of the first 3 months is y is approximately 1100 divided by 100 plus 1400. I don't need to simplify this, and I am done right here. I have completed part A. I got my equation of the line tangent completed, and I got my approximation completed. We know it is 1400 plus this amount of solid waste. And again, not calculator active, no need to go ahead and try to show your work and do anything that's going to take a significant amount of time. So let's go ahead and move on to part B. Okay, we are now on part B. Now part B is a little bit tougher, and I'll show you how you do this problem because I know the answer key probably is not helpful for these type of problems considering how tough they can be. So first thing for us to do is we need to find the second derivative of W. So we need to take the derivative of this function here, and then we need to use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. Now, I want you to think about this for a moment and think to yourself, well, what in the world does the second derivative tell me? Well, the second derivative tells you concavity, whether it's concave up or whether it's concave down. That's going to let us know then whether things are over or an underestimate, and I'll draw you a picture in a moment. So let's just go at this one step at a time. Let's take our second derivative. Now, me personally, to take the second derivative of this function, I could use the product rule, but I'm just going to distribute the 1 over 25 to both sides. I don't know, for me, that just seems like it's going to be a little bit fast. Okay, I went ahead and distributed the 1 over 25 to both of these. I get 1 over 25 times W minus 300 over 25. Now we're going to go ahead and take our second derivative. The reason why I wanted to distribute this is because the 1 over 25 is just a constant, so I know when I distribute this across, right, if I go to write this out like this with respect to t, you're gonna notice right here that, well, what's the derivative of 300 over 25? That's gone, that's 0. Now, one thing I want you to keep in mind is that this is with respect to t. There is no t variable, so when I take the derivative of w, this is gonna be 1 over 25, it's just a constant, times the derivative of w would not be 1 because it's not with respect to w, it's with respect to t. So this is going to be dw over dt. Now that looks a little bit strange, but no worries. Here's the good news. Do we know what dw over dt is? Well, in fact we do. dw over dt is actually right here, or this one right here. So all we need to do is plug this back into dw dt, and we're going to have our second derivative. So it's going to look something like this. All I did was take the dw dt and replace it for this entirely. So I took this entire thing and I just replaced it, and it's all right here. Now that's going to solve part B. I have already taken my second derivative. There's nothing for me to do. Now it says use your second derivative to determine whether your answer in part A is an underestimate or an overestimate of the solid waste at t equals 1/4. Well, there is no t value to plug in, but we do need to plug in a w. So I want you to take a moment to think about, what do I need to plug in into w? So what are we going to plug into w? Well, what we're going to plug into w would technically be the approximation, right? We want to know if the approximation is an under or over representation. So we're going to plug this in right here to w. Now, if I go to part B and I plug in that value into w, I want you to think about what's going to happen here. If I plug in to w right here, the 1100 divided by 100 plus the 1400, okay, I want you to think about what's going to happen to the value of all of this. Again, you do not need the answer for this. You just want to know whether it's concave up or concave down, very similar to the problem we did in 2010. Let's see if this can kind of make sense and put it all together. If I plug all this in to W, I'm going to get a positive answer, right? Because 1400 plus this minus 300 is going to result in a positive solution. This positive times positive is positive. This positive times 1 over 25 is positive. So now I know that when I plug in this value, I'm going to get this to be greater than 0, which means it's concave up. So now if I was to go to this graph real quick, that tells me my graph is concave up. Now if I was to draw my equation of the line tangent, which is this right here, let's say that this was this value right here was the 1000 at t equals 0. I know this is not I know this graph is not like perfect. It doesn't actually match the problem. I just want to give you the idea. This is the t value we're plugging in right here, and this is my approximation. Now, we basically plugged in t equals 1/4, right? So we say we plug in t equals 1/4, which is just a little bit over my approximation. Well, if you look, it is underneath our curve. Do you see that? Because it is concave up, right? Because we are in the region of it being concave up, my approximation should be an underestimate of the actual amount. This is the actual curve. This is my line tangent. This approximation is under this curve right here. So this should be an under approximation. So what I'm going to say is, you know, I will say since the second derivative is greater than 0, it is concave up. Therefore, and maybe I'm not going to write it out just for the sake of time. Since our second derivative is greater than positive, it is concave up. Therefore, at t is equal to 1/4, the answer in part A is an underestimate of the amount of solid waste at the landfill contains, and that would be my answer for part B right here. So if you notice, anything that asks second derivative and whether it's an over or under is going to involve, in my personal opinion, concavity, concave up or down, and then it's going to give you whether the approximation is over or under. So hopefully that made sense, guys. Again, this is in conjunction with 2010. You'll notice that these were a little bit tough. Let's go ahead and move on to part B. All right, in part C, we need to find the particular solution, W equals WT to the differential equation. So you know this means we need to find the original, which means we need to do separation of variables. So we're going to go through this rather quickly now. Again, hopefully this is the part that you feel good in. Again, that other problem was pretty tough, I'm not going to lie. So, you know, if that's still a little confusing, that's okay. I know these problems can be, in my personal opinion, can be pretty tough. Anyhows, we're going to divide W minus 300 of both sides, multiply dt. So what we're going to get over here is 1 over W minus 300 dt is equal to 1 over 25 dt. Now we can go ahead and take the antiderivative of this perfectly. When we take our antiderivative, the antiderivative of this, there's no power, it's going to be ln. So we're going to get ln absolute value, W minus 300, boom, is equal to, and then we're going to get 1 over 25. And remember, this is not x, it's t, right? So 1 over 25. So that's what my antiderivative should look like. The one note I will make here is, don't forget, we're going to take the derivative of this inside. The derivative of W is 1, so we need to divide by 1. But you don't need to show that for this problem because it's just 1. So just keep in mind with ln, you still got to undo the chain rule there. So let's go ahead and plug in the 0 into t. That's going to be gone. So we get c is equal to, and let's plug in the 1400. So we get ln of absolute value 1400 minus 300 here. So we're going to get ln of 1100. Absolute value of that is just 1100. So this is my c value, and now I can go ahead and plug that back into my original here, which I'll do and write it out. All right, now that we have this function all written out perfectly, we plug the c value back into the c, ln of 1100. Now we're going to raise e to both sides here. That's going to get rid of this e's, and we're going to get w minus 300 is equal to e to the this entire thing right here. I'm not going to write it out for the sake of time. And then the last and final step is to add 300. So then I'm going to do plus 300 over here. Now, if you notice, even though I didn't fill this out, it's going to be in here. I have a set of parentheses so that the AP readers know that this was e raised to the power of all this plus 300. So then W equals e to the blah, blah, blah plus 300 right here. So hopefully this made sense, guys. You'll notice as the videos progress, I am going through them a little bit faster, but hopefully it's all coming together as we're going through the years and the progression. Take care. Capiche.